everyone. So this is our follow-up to earthquake intensity. So the first question that we answered was the where. We plotted epicenters and we figured out where the earthquake occurred. And the second thing that we're talking about is how big was that quake? How do we measure the intensity of earthquakes? So like I said in the last video, you should have read through this on page 41 and the notes pack, and you should have read through page 42 in the notes pack. And then I just went through these slides with you, some of these slides, and we'll get to tsunamis and damage another time. But I'd like everyone to please turn to page 48 in the notes pack. Please turn to page 48 in the notes pack. If you have to take time to get that done, then please do so. So you should pause the video and do that. So you should be back now. So basically this activity is how big was that quake? And I used to do this activity as like enrichment because it was like I didn't think it was fair game. And then one time about 10 years ago, they just showed up with this question and they gave procedure on how to figure out the Richter scale. And it's very easy, but it's kind of fun. So let's read through the introduction. The Richter scale is used to determine how powerful a quake is. Similar to the brightness of stars, which we're going to learn about soon, the intensity of the earthquake to the observer is dependent upon their distance from the quake. This chart is used to determine an earthquake strength. First, you're going to place a point on the left side equal to the quake's distance from you. So this is your distance to epicenter over here. Then you're going to place another point on the right side for the observed amplitude of shaking, and we're going to use a seismogram reading for this. Last, you're going to draw a line connecting the 2 points. The intersection of that line in the middle scale is the Richter magnitude of the quake. So you saw this diagram in action in the video that we watched at the end of the last video. So the example that they give you is a quake with an amplitude of 1 millimeter, so that's right here, and a distance to epicenter that is 100 kilometers away. You would make this point and that point, connect it with a line. That would give you a Richter magnitude of 3.0. And remember that an increase of 1.0 on the Richter scale is equal to about 10 times the amount of energy released by the earthquake. So a quake that's a 6 on the Richter scale is 1,000 more times powerful than our practice problem. So the first three, they're going to hand us the data on a silver platter. Okay, they're telling us that the seismogram reading is a 10 millimeter amplitude and your distance to epicenter is 500 kilometers. So we are going to put a dot at 10 millimeters and a dot at 500 kilometers away. And you're going to need a straight edge now. So if you need a straight edge, you can pause the video and go get it. You can use a ruler. You can use a compass if you had a compass. You can use the edge of your ESRT if you need to. You could use any straight edge. I just pulled a few from my house. Any straight edge whatsoever. Even your green sheet will work because it's when it's folded, it's 2-ply and it's thick. So we're going to take our straight edge. I am going to use my metric ruler. We're going to take our straight edge and we're just going to, here's the dots. Okay, so we're just going to very carefully line up our ruler with our 2 dots that we made. And we're going to connect them with a line. And what's the Richter? I'll zoom in. What is the Richter magnitude of that quake? And we go into the nearest 10th. It looks like it's closer to 5.7. I'm going with 5.7. Okay, so the Richter magnitude of that quake is a 5.7. A 100 millimeter amplitude reading, that's pretty big. That's 10 centimeters displacement on the seismogram. You're going to learn what amplitude is in one moment. That's only 30 kilometers away. So now you're 30 kilometers away. You're pretty close to the earthquake. What's the Richter magnitude of that earthquake? So we're going to take our straight edge. We're going to connect those points as accurately as we can. And I'll zoom in again. What'd you get? I got 4.2. 4.2. So that's a 4.2 on the Richter scale. Okay, let me show you what amplitude is. Okay, so everyone go to page 49, please. This is a seismogram reading, and we've looked at these before, okay? This is our baseline. What baseline means is like you know, there's no quakes in the area. The needle is just kind of moving along, moving along. It's kind of hanging out in that area. And all of a sudden, woof, it starts shaking. You know that an earthquake occurred. This around here, this is the arrival of the first P wave, and that's the arrival of the first S wave. Now, the amplitude is the distance measured in millimeters from the baseline to the furthest point either above or below the baseline. So if we look at the seismogram reading, you pick out the highest point above the baseline and the lowest point below the baseline. So here's the highest point above the baseline, and there's the lowest point below the baseline. So what you need to do is you need to measure both of those from the baseline, So on this one, we're going to put the 0 on the baseline and measure up, and we're going to put the 0 on the baseline and measure down. And we're going to do that in one moment. But thinking about this, what is the relationship, the generalized relationship, showing the relationship between the amplitude and the distance from the quake, the distance to epicenter? So we think of it as a relationship statement. As the distance from the epicenter increases, as you get further and further and further from the epicenter, what is your seismograph going to do? Is it going to shake more or less? If you're right near the earthquake, the ground's going to shake like crazy, right? So what is the independent variable? Which variable doesn't care what the other one's doing? Which one's going, I'm going to continue on my merry way and you don't affect me at all, right? That's the independent variable. The dependent variable is like, oh my God, I'm going to be totally affected by you because I'm dependent. Okay, so the independent variable is the distance from epicenter. What are our generalized descriptors to qualify that? Close and far, short distance, long distance. I'm going to put close and far. Close to epicenter, far from epicenter. And our dependent variable is amplitude of seismogram. So when we're measuring amplitude, it's in distance. So what do you think? What are the two qualifiers here? Amplitude, low amplitude and a high amplitude. So if you're close to the epicenter, tell me about the amplitude of your seismograph. If you're close to the epicenter, the ground is going to shake what? The ground's going to shake a lot. So that's a high amplitude. And if you're far from the epicenter, that's going to be a low amplitude. So it's going to be, what kind of relationship is this? This is an indirect relationship. Okay. I want you to do these two questions on your own, and you're going to check the answer key tomorrow. You're going to use this right here to help. Okay. Now, since not everyone has a metric ruler at home, we're going to collect this. We're going to do this together. Okay. We're going to do this section together. We're going to collect some data together, and then I'll ask you to do a couple of answers yourself. Excuse me. My voice is gone. Okay. So we need P wave arrival, S wave arrival, S minus P lag time or time difference. That's going to allow us to determine the distance from the quake. Now, keep in mind, we're using this data table. We're not using the ESRT to get distance from quake, because the difference, the S minus P lag time is in seconds. And our P and S wave table does not allow us this exactness, okay, this precision. So we have to use this right here, okay? So let's read our seismogram. What is the best time for the P wave arrival? Let's figure out our scale. 2209 32.0. We have never seen a scale this exact before because we're pretty close to the quake. 2200 hours is 10 p.m. 09 minutes, 32.0 seconds, and that is p.m. You with me? Okay. So this is 2209.32. This is 40 seconds. This is 50 seconds. This is 10 minutes, right? That's 60 seconds. Okay. So let's figure this out. If this is 32, 33, 34, 35, 36, 37. So what is the P wave arrival time? 2209.37. So 2209.37. S wave arrival. So it's right about here. So right there. So 40 41, 42, 43. So 2209, 43. Okay. The last piece of your data I'm going to give you is the amplitude of the quake. All right, because again, not everyone has a metric ruler at home, so I want to show you what the data is for this. So again, we need to figure out what is the greater amplitude. Is it this high point from the baseline, or is it this low point from the baseline? So I'm going to put the ruler here. Hopefully everyone's going to be able to see. All right. So if I put the ruler here and I ask you the number of millimeters. Okay, is that on there? That is on there. Okay. So 1 centimeter is 10 millimeters. And how many more? 11. I want to say 12. What do we want to say? 11 or 12? Let's go with 11. So this is 11 millimeters, this one. Okay. And then we're going to measure from the baseline down to there. So what is that one? That is 10, 11, that's 13, right? So if we measure from, hold on. So this is 10, 11, 12, that's 13 millimeters. So the farthest amplitude, the furthest amplitude that this seismogram got away from the baseline is 13 millimeters. That's how much it shook. So we know the 13 millimeters. So you're going to get the difference here. That's going to allow you to do distance to quake. Okay, so here's the seconds. Use that difference to get the distance to quake. Put a dot wherever that dot should be. Then you're going to put a dot on 13 millimeters and you're going to get the Richter magnitude. All right, so you're going to finish that up and then you're going to check your answer key tomorrow. All right. Now, the next 2 pages are about Mercalli, and I'm going to ask you guys also to take a survey, and I'm going to see how many people can actually print something out, because I'd like to do the lab that we normally do for Mercalli, but you have to be able to print it out because we have to draw ISO lines and do work on it. If a lot of people can print it out, then we'll learn about Mercalli scale on these 2 pages. These 2 pages and these 2 pages here. Okay, so this is Mercalli scale. So again, we're going to learn about Mercalli scale, but I prefer to do the lab, but if not, no worries. We can do these 2 pages and Mercalli scale will become clear to you. Okay. So I'll see you next time, everyone, and have a good day. Bye.